Welcome to this session. Today we talk about measurement, physics chapter 1 ICSE pattern. Physics chapter 1 class 7 ICSE pattern measurement. Now we are talking about measurement of mass and weight. What is mass? We know every object that we see around, every substance, every material has some quantity of matter. Now irrespective of the volume and size. Why we say irrespective of the volume and size? If you take cotton will be very voluminous. Also, some bales of cotton will be large in size. It has mass. How much mass it's there? Mass will be less only, but volume will be more. The mass remains the same irrespective of the force applied. The mass in a cotton, the mass in a balloon, the mass remains the same. The size may change a little bit, but the mass will remain the same. So mass is a quantity of matter that remains the same irrespective of the force applied, irrespective of the volume and size, and the mass remains same at different places. What do we mean by different places? The mass on the equator is same as the mass in the North Pole. The mass on Earth is the same as the mass on Moon. So mass remains the same at different places. Mass is a quantity of matter. Irrespective of the volume and size, it remains same irrespective of the force applied and remains same at different places. Now there is something called gravitational force. What is gravitational force? Gravitational force is the force applied or caused by the gravitation of a cosmic body. That means what? Earth has its own gravitational force, Moon could have its own gravitational force, Venus, Mars, Jupiter, everything can have its own gravitational force. But in general, when we speak on Earth, gravitational force means force of the Earth or the force with which everything is pulled towards the center of the earth. So gravitational force is the force with which everything is pulled towards the center of the earth, or for that matter to the center of the moon when it is closer to moon. Now this gravitational force is applies irrespective of the size, volume, shape or state. State is what? Solid, liquid, gas. Shape could be circular or spheroid or cubic, etc. So irrespective of the size, volume, shape and state, the gravitational force, that is the force that attracts anything towards the center of the earth, applies on everything. While mass is the quantity of matter that remains the same at different places. Now what is weight? Weight is the force with which earth attracts a body towards it. The force with which the earth attracts a body towards it is called the weight. So any quantity or any matter or any material or any substance has a mass, that is a quantity of matter. Earth attracts anything, everything towards it, that is called gravitational force. The force with which earth attracts a body towards it, the force with which the earth attracts a body towards it is called the weight. So this weight varies from place to place. Mass is same, gravitational force is the force of attraction towards the earth, and the weight of a body depending on the mass and the constant gravitational force changes from place to place. How? It depends on how far it is from the center of the earth. So if you are closer to center of the earth, there will be a higher level of or a higher weight. So this is how mass and weight are defined. Now in moon has a gravitational force which is 1 by 6 of the earth. So the gravitational force is the force with which a body is attracted towards the center of the cosmic body, towards the earth or towards the moon. The gravitational force of moon is 1 by 6 of earth. So if you are 30 kilo on earth, you will be 5 kilo in the moon. Due to the force of gravitational field of the moon's force on your body, mass is less than the gravitational field of the moon's force on your body mass. The gravitational field of the moon's force on your body mass is less than the force of the gravitational field of the earth on your body mass. Your body mass remains the same. Your weight changes from 30 kilo to 5 kilo because the force of the gravitational field of the moon on your body is 1 by 6. The force of the gravitational field of moon is 1 by 6 of the force of the gravitational field of earth on your body mass. Your body mass remains same. It remains the same. That is the quantity of matter on your body. The number of bones, the size or shape of the bones, or the flesh, the tissue, the skin, the blood cells, the Every cell of your body, the body mass remains the same, but the weight is different. Now, what is unit of mass? Unit of mass in SI system is called kg, kilogram. What is SI system? International standards. Standards international is kilogram, kg. What is CGS system? CGS system is a gram second system. There, G is the unit of mass. So you have studied SI and CGS in the previous class. Now you find that unit of mass is kilogram kg. In CGS system it is g gram. So what is 1 kg? 1 kg is the mass of 1 liter pure water at 4 degrees centigrade. Now when it is not at 4 degrees centigrade, the water will not remain as water. The state, there will be a small change in the state, because below that it may start freezing. Now pure water and the impure water has differences because of the salt content or the basic and acidic elements dissolved in the water. So mass of 1 liter pure water, that is 1000 ml, 1 liter is 1000 ml at 4 degrees centigrade is called 1 kilo. So if this is 1 kilo, then the apple that you buy will be 3 kilo, or the something else that you buy will be 7 grams. This is like that. So unit of mass is kilogram. When you buy something from the shop, you are buying it kilogram, right? Or smaller things you buy at gram. Medicines and all will be in grams. So this kilogram or gram is with respect to mass of 1 liter pure water, 1000 ml at 4 degrees centigrade. This is 1 kilo. If this is 1 kilo, how much is the apple or the rice or whatever you buy? Now what are higher units? Kilogram will become quintal when 100 kilo is 1 quintal. 1 quintal is represented by Q. Quintal is represented by Q. Then there is still higher measure, metric ton, T or MT. Metric ton is T or MT. This is 1000 kilo. This is 1000 kilo. Now what are the subunits? If there are the higher units, subunits are 1 milligram. Milli means what? 1 by 1000. How do we write 1 by 1000? 10 power minus 3. 1 gram. 1 gram is 1 by 1000 of a kilo. That is 10 power minus 3 kilo. Milligram is 1 by 1000 of a gram, and a gram is 1 by 1000 of a kilo. So 1000 grams is 1 kilogram. These are the units of mass. What is a kilogram? Kilogram is mass of 1 liter pure water, 1000 ml at 4 degrees centigrade. Now there are nanoparticles. We know that atom is the smallest indivisible part of any element, which cannot be further chemically made smaller. Now we know that it has a nucleus. Nucleus has protons and neutrons, and in circles, in shells, K, L, M, N shells, the electrons move around the nucleus. First shell will have 2 electrons, next shell will have 3 electrons. All these are nanoparticles, very minute, fundamental particles. Now how do we measure the weight of them? They are measured in atomic mass unit, AMU. That was a earlier measure. Now later people introduced unified mass unit. Unified mass unit is written as mu and called as Dalton. So atomic mass unit or unified mass unit is the unit of measure of mass of nanoparticles. For liquids, we measure the volume. How? In liters or milliliters. 1 liter, 1000 liter will become kiloliter, and 1 by 1000 liter will become milliliter. Now, for measurement of mass, we need some instruments, one devices. So, with this device, we will measure. How actually we measure? We measure by comparing. We know what is one standard, and then against that standard, we measure. So, 1 kilogram is nothing but mass of 1 liter pure water 100 ml at 4 degrees centigrade. Now if you know that, and if you have on one side, then on the other side, depending upon how many apples you have or how many rice grains you have, you will know how many kilo it is. So this is one way of measuring. Now for that we have a standard mass of weight. Weights are made of iron, brass, etc. Weights are made of iron, brass, etc. When we say weight, this is what we mean. This is the standard weight. Iron, brass, etc. I can show a bigger picture. So this is the weights that we are talking about. Now this weights is there on one side. We will compare this weight against the weight of the object that you are putting to understand how much weight is the object that you have input. These are made of iron and brass. Normally the measurement of weight is by instruments called beam balance. What is beam balance? You will have a beam like this, or you will have a beam by like this, or you will have a beam like this. And this beams will balance. When it balances, when both sides are equal. It is also, we have devices called digital platform balance. This is a platform balance, this is a digital balance, this is a physical balance. So we have beam balance, physical balance, digital balance, platform balance, etc. Different types of balances. Why it is called balances? Because based on whether it is balancing or not only, we measure the weight. The weights are made up of iron and brass. So compare with a standard mass. This is a standard mass, and against it you compare the vegetables that you buy or the fruits you buy. The pans are of equal weight. They are tied at equal distances. They are tied at equal distances from center. This distance is equal. At the ends by a rod. This is a rod. At equal distance on that rod, the pans are tied using strings. The strings are of equal length and equal weight. That is equal mass. Why? Because the pan on either side or a string on either side should not cause any differences in weight. And this is equidistant. So this will also not cause any weight. And this rod is suspended with a loop with a pointer in the center. This pointer moves in either direction. Here also you have a pointer. The pointer moves in either direction and it will tell you whether this weight is more or the object that you put is more. And if it is equal, then the pointer will be in center. That means it will balance. That is why it is called a balance. So drawing this, labeling the parts and naming it is what you should be knowing when we talk about how we measure the mass. The pans of equal weight and equal mass. Equal weight means what? Equal mass are placed at equidistant from the central rod. The rods and the pan are connected by a string of equal length and equal mass, and the beam is suspended with a loop with a pointer in the center. Beam balance. What is the principle? The principle is when the rod is horizontal, the pointer is vertical when the pans are empty. The beam balance principle is the beam, the horizontal beam, the rod is horizontal, and when it is horizontal, the pointer will be vertical. And when this is in horizontal and vertical position, when it will happen? It will happen when the pans are empty. Why? Because the pans are of equal mass, the strings are of equal mass. Now, two bodies of equal or same mass will ensure the beam to balance. If it has of equal weight or equal mass, what will happen? The beam will balance. That means what? The rod will be horizontal, the pointer will be vertical. The equal content in the pan as well as the pans being empty is the same. That is two bodies of equal weight. Why? Because the pans are hung at a point that are equal distance from the center. Pans are of equal mass, the arms are of equal length, the pans are hung from the equal distance from the center, and so the beams will balance. And if a beam will balance, it means when the rod is horizontal, the pointer will be showing vertical. Now keep the body whose mass is to be measured on one pan, the object. Keep adding or reducing the weights on the other, the weights made of copper or brass on the other, till the rod balances. That is, the pointer strictly vertical on the scale when held up. When you hold the balance, it will be vertically on the scale. Now, when it balances, that means the number of weights that you placed on one side of the pan is equal to the actual weight of the object on the other pan. The number of weights that you place on one pan to ensure the rod balances and the pointer strictly vertical on the scale is now gives us that the number of weights that you placed on one pan is same as the weight of the object on the other pan. This is the principle of the beam balance. When the rod is horizontal, the pointer is vertical. When the pans are empty, when two bodies are of equal mass, then the beam will balance. That means the pans are of equal mass and the arms are of equal length and the pointer is vertical. Now, sum total of the weights is equal to the mass of the sum total of what? Sum total of the weights that you place by adding or reducing to see the rod's balance. What is unit of big weights? Unit of bigger weights is Newton in SI system. This weight is different. This is a physics weight. The other weight that we saw 1 kilogram, this 1 kilogram weight is actually unit of mass. If water 1 liter at 4 degrees centigrade is having 1 kilo mass, then how much mass you have? This is the commercial weight that you talk about, 1 kilogram. This is a different weight. Now the weight that we talk in physics is measured in Newton. In SI system N and the dyne in CGS system. Newton in SI system indicated as N and dyne in CGS system. So how many dynes is 1 Newton? 10 power 5 dyne is 1 Newton. 10 power 5 dyne is 1 Newton. Weight of body mass of 1 kilo is 1 kgf. Weight of body mass of 1 kilo. What is weight of body mass of 1 kilo? Mass of water 1000 ml at 4 degrees centigrade is 1 kilo. When something is of like this, when something has weight 1 kg, then what is the actual weight? Weight of the body mass is 1 kg means actual weight will be 1 kgf. This weight is a physics weight. This weight is a commercial weight 1 kgf. So what is 1 kgf? It is 9.8 Newton. 1 Newton is 10 power 5 dyne. So 9.8 Newton means 1 GF equals to 989. 1 kgf is 9.8 Newton. 1 GF 989. This will help you in 1 mark questions when you are writing some exams. 1 kilogram body mass will have a weight of 1 kgf, which is 9.8 Newton, which means 1 GF. Kgf is kilogram force. GF is 980 Newton. What is GF? Dyne in CGS system. Newton N in SI system. The relationship between Newton and dyne is 1 Newton equals to 10 power 5 dyne. Now let us look at measurement of weight by a spring balance. Now what is happening is there will be a spring which can move up and down, and then at the end of the spring there will be a hook for holding the object or hanging the object. This spring will be hung on a fixed top. This has a scale. Now because this is a spring, when the weight is there it is pulled and come down, and weight is not there it will go back to normal. This is called a hanger, this is a pointer, this is a scale calibration, this is string being pulled down by the object. What is one important requirement? The spring should be capable of going back to normal or zero calibration when there is no weight. Now, the upper end of the spring is fixed, lower end is attached to pointer, object is hung, pointer reading on the scale represents the weight. The pointer reading on the scale represents the weight. This remains same irrespective of the force applied. So, gravitational forces, Earth attracts everything towards the center and irrespective of the size and shape that we know. We also know mass is quantity of the matter contained, while weight is a force acting on the body, pulling it towards the earth. Mass can never be zero. It is a scalar quantity. It is measured by beam balance. SI unit of mass is kg or gram, and mass is constant, independent of the place or position. Mass can never be destroyed. Mass can never be destroyed. It gets converted into energy. It can never be destroyed. Weight is a force acting by pulling the earth, pulling towards the earth. Weight can be zero. If g equals to zero, weight can be zero. Gravitational force. It's a vector quantity. The scalar quantity, vector quantity is measured by spring balance. Measured by spring balance. SI unit of weight is Newton and varies dependent on the place and gravity. So that is why here we said it will remain same irrespective of the force applied, because it's a measurement of how many newtons. The spring balance is used for measuring how many newtons we have. Okay, thanks for watching this video. Please keep coming back. We shall meet with another video in the next session.